Hello and welcome. This is Matthew, and today we will be adding a Rexx interpreter to our MVS 3.8 system. And the interpreter we're going to use is the BREXX 370 interpreter. This is a piece of software that has been ported from the BREXX implementation of Rexx to the S370 platform so that we can run it under MVS by two gentlemen, Peter Jacob and Mike Großmann, who are active members of the Moshix mainframe community. In fact, if you have trouble or you need to get in touch with them or you just want to talk about any of this fun mainframe stuff, the project page has a link to the Moshix Discord channel right here. And so what Mike and Peter have done is ported this existing open source BREXX implementation, like I said, to the S370, and they've packaged it up, if we go over to the releases page here, and a nice package that we can download and pretty easily install and integrate into our MVS system. So that's what we'll be doing today. I'll include the link to the GitHub repository and this releases page in the video description, so you can look below for that. And we will be using the V2R2M1 release in this video. This is the same software as the V2R2M0 release, but as the note here says, it just has an updated installation manual. So I guess there are some clarifications or some fixes based on other folks' experience and feedback having installed the software. So let's go ahead and download this zip archive. Let me copy that link and switch over to our console. Let me go over to my Linux shell. And in the downloads directory, I'll just wget that archive really quick. All right, and we can unzip that. And it creates a folder for us with all of the contents in it. So if we look inside that folder, you can see that we have a transmit archive. And so we're familiar with those from some previous videos. We have a user's guide. This includes information on how this implementation on MVS differs from the core BREXX or the original BREXX implementation, I believe, and some other Rexx implementations you may be used to. So good information in there. This implementation also has vSAM support and full screen support for 3270 terminals. So lots of interesting things we can play with here. I really don't know the Rexx language, but having this available on my emulated mainframe certainly makes me want to learn a little bit more and see what I can do with it. But most importantly for now, we also have the installation guide document. So I have that open. If we look back over in my browser, I already have that open here, and we can start up at the top. And this will be the framework we're following to install the BREXX 370 package today. I should note, in talking to Mike and Peter, they are hard at work on version 2 release 3, and that will be included in the TK4- update 9, which, if all goes well, is scheduled to come out sometime this summer. That'd be Northern Hemisphere summer. And that'll be nice to have that pre-integrated into a TK4 package, along with any other enhancements that come along with that. So you can keep an eye out for that. And again, my understanding is when the TK4- update 9 is released, V2R3 of this BREXX 370 project will also be released. All right, so with that, let's begin. So we do not have MVS TK4-. We have our own MVS 3.8 system that we built following Jay Mosley's instructions. You can watch that process in previous videos. And generally, I'll assume that if you're following this set of videos, your system reasonably resembles the work we've done to that system so far. But again, that's not a problem. MVS 3.8 is the same operating system that TK4 packages, so this should go pretty smoothly. So it'll be interesting to work with Rexx and ISPF panels. I think that's something that all of that should work together in the TK4 Update 9 release this summer. So that'll be pretty exciting to work with. For now, we'll keep it simple, and we don't have ISPF installed yet. And the first step here is to create an alias for BREXX. So everything's going to be loaded with the high-level qualifier BREXX. We don't want all of that cataloged in our master catalog. So let's add an alias for BREXX and make sure that gets cataloged in our user catalog. So we do that with the IDCAMS program, IDCAMS. Let's log into our mainframe and we'll get this process started. Okay, so we need to make a quick JCL job here to create an alias. I'll put that in my control library, and I'll make a new member here just named alias, and I'll keep this around just so we have a template to make any aliases in the future. We'll call it mwilson A for alias. This job will make sure our messages go to our held output queue. And the IDCAMS exec, we can just run directly as IDCAMS. Give it a sysprint for output. That'll go to sysout. And I believe the only other thing we need is sysin to provide the commands to IDCAMS. So to create an alias, we say define alias, and we give it a name. This will be BREXX. So that's the high-level qualifier that we are aliasing. And then we will relate it to another catalog. We want that to be cataloged in the UCPub 000 catalog, which again is one of the user catalogs we created when we built this system. And we'll just wrap all of that up. So double checking it, we're running IDCAMS, providing it the input, define alias, name BREXX, relate, UCPub 000. That should work. Let's submit that. And we will start our output viewer in another RFE session here. Okay. So that job is still running. And the reason it's just sitting here still running is because we have a password on our master catalog. And we can see that my screen program here is telling me that there was a bell over on my MVS master console. So let's go to the master console. You can see it's asking us for the password that's protecting our master catalog. So if you were following Jay Mosley's instructions and haven't changed it, that password will be sysprog. So I can reply to message 1 with sysprog. And we can see here that that job completed with a condition code of 0, which means it worked. So back over here, let's refresh that. And you can see that job mwilson A, again, has completed successfully. And if we go down to the bottom, IDCAMS just says function completed. So that looks good. Let's clean up our output queue here, just so it's easier to work with on future jobs. And we'll switch back over to our editor session here. So that's the alias. Let's go back to the instructions. Step 0, unzip the installation file. Okay, we've already done that. We have all of these files. And we need to transfer the transmit file to our system. So as you have seen in previous videos, there's a couple ways we can do this. We could read this in through a card reader, but since we installed InFile in one of the previous videos, we can go ahead and just transfer this through our 3270 emulator. So let's do it that way. There's a note here that when we upload that file, it needs to be fixed block with a logical record length of 80. That is typical for transmit files. So let's go back over to our mainframe. And remember, whenever we use the file transfer capability through the terminal emulator, we need to be at a TSO prompt. From RFE, being at the RFE TSO prompt will work as well. So I'll just leave it at this prompt, and then I'll hit Control right square bracket to bring up the C3270 prompt. we'll use the transfer command, and then we'll just go through and answer the questions. So we want to send a file up to our mainframe. And this file is in home, mWilson, MVS, downloads. And let me just copy and paste the path names here so I don't get it wrong. And then the file name is our transmit file, this guy right here. Okay. Name of destination file on host. So what do we want this to be called on our mainframe? We're going to use a fully qualified name, so I'll put it in single quotes, and I'll just upload it to mwilson.brex.xmit. Host type is TSO. We're going to transfer this as a binary file, so no translation is done. And file record format we want to ensure is fixed with a logical record length of 80. I'll just use 5600 as my block size. And then the rest of this will use default, and continue. Yes. So this will transfer that transmit package up to our mainframe. Looks like there's quite a bit in there. Okay. Looks like that worked. Just under 1.5 megs, it looks like. Not too bad. So we'll hit enter. And now if we go back to browse, oops, it's already typed in, mWilson, you can see that we did receive our mWilson.brex.xmit data set here. Okay, back to the instructions. So as you would guess, now that we have that transmit file, we need to restore it. We need to unpack it. So there's a sample job here to use receive 370. You'll recognize this and these various DD names here from my previous video on using receive 370. And if you want, you can certainly copy this in. And if we're going to use this on our system, a couple of things to be aware of. On the way that my system is set up, my held output class is X. So I would change message class to X. And also, and we may see this later, for some reason that I don't understand, on my MVS system, I am not able to allocate an 8 megabyte region. It needs to be smaller than 8 megabytes. So if you are using this as your template on an MVS system built according to my videos and Jay Mosley's instructions, just be aware that you'll need to use a smaller region size. And receive 370 doesn't need 8 megs, so it'll be fine. There's also another important note here that we need to use 3390 volumes to work with this. You'll see here if you use your own JCL, make sure we use a 3390. There has been reliability problems during testing when people have attempted to restore this package to 3350s or presumably 3380s. So we'll make sure we're using a 3390. Now, I already have some received JCL from the last time we were using receive 370. So we'll flip back over to the mainframe, and keeping in mind the notes that we have here, we want to restore to brex.v2r2m0 install. We want to use a 3390 volume. We'll go ahead and modify our receive JCL to receive this package that we downloaded from GitHub and uploaded to our mainframe. So I have my receive job in my control library here. And there it is. I'm just going to edit this existing library we have, or this existing job we have. This is my receive job. We have our step lib because our receive 370 executable is over here in sysc link lib. And the first thing we're going to make sure of is that we are using a 3390 volume. And on this system, I need to explicitly specify our one 3390 volume, which is the volume with the serial number pub 001. The file we are going to receive is mwilson.brex.xmit. So that's the file we just transferred up to the system. And we will put it at a new data set here, which will be BREXX, so that high-level qualifier we created an alias for, dot v2 r2 m0 dot install. We have an overflow. Those are blank characters at the line, end of the line here, so I'll just delete those, and then I'll be able to type more. Yep. Install. Okay. This also needs to be on a 3390 volume. So we will do that. We don't need a DCB line here. We're going to say vol equals serial number pub 001 to make sure it ends up on that pub 001 3390 volume. And the space, let's look back over at the instructions. It looks like we're going to need 300 tracks and then 600 for additional extents that are allocated and 20 directory blocks. So we're dealing with tracks 300, 60, 20. 300, 60, 20. And 10 cylinders here for the temporary space with additional growth should be sufficient. Okay, so we're going to receive it. Our input is mwilson.brex.xmit. Our temporary space is on the 3390 volume pub 001. And our new data set is going to be brex.v2r2m0.install on the 3390 volume pub 001 with adequate space allocated to hold everything that was in that roughly 1 megabit package. So let's submit that and see what happens. Okay, switch over to our output queue. Looks like there was probably a problem here. JCL error, so let's see what I did wrong. Keyword in the unit field is mutually exclusive. Oh, I have unit twice here on line 7. So let's go ahead and purge that output, switch back over, fix that mistake, and try again. Switch to our output, see what it says this time. Okay, we got a condition code of 0, which is what we want. If we get down to the bottom here, you can see that we did restore several members into that new data set that we created. So far so good. I'll go ahead and purge that. So let's take a look at what we got. There should now be in our BREXX high-level qualifier. Yep, we have this BREXX v2r2m0 install package. Let's browse that. And what we have here are several more transmit packages that are ready to be received into individual data sets under BREXX v2r2m0. So let's go back and check the instructions and see if there's anything special we need to be aware of here. So it looks like we have a number of JCL jobs that will perform the next steps in the instructions. So unpack This is going to unpack these transmit packages into their destinations. Install will copy the executable materials into our sys2 link lib and command lib, I believe, so that those programs are available for us to run on our system. There's a test job here. We'll be able to exercise the functionality of BREXX and make sure that all of the test BREXX scripts run. And then we have a cleanup job that will remove some of these files we don't need anymore once they've been installed into the system locations. So we need to run the unpack JCL. And we'll take a look at this JCL, but it looks like we'll just need to make sure we have the right location where we unpacked the distribution file. All right, so it looks like it will also attempt to remove any old versions, so we can expect some return codes of 4 on some of the steps, with the unpack steps returning a code of 0. So let's go run that unpack job. We'll edit. I'm going to rename it just so it's easy to, I'll rename it M. Wilson U. I need to turn off there's a setting in C3270 that will work around this line overflow problem, but I need to look up what it is. So we'll call this M. Wilson U for unpack and change the message class here to X to match my system. And we need to change our xmit lib to where our installation library is. So brex.v2r2m0.install is correct. And it looks like, let me page down here. So it looks like this is a JCL procedure that we're then going to call for each library that we need to unpack. So it is going to run a TSO command to delete the old version of the target file. And then it will run receive 370 to unpack the new version of the target file. So it looks like we will need to add a step lib dd here, because again, our receive 370 is in sysc.linklib. So if we didn't add that line, JCL would tell us, I have no idea what receive 370 is. So we can just add that step lib. And it looks like, again, this is going on unit 3390. We want to specify vol serial pub 001. Remember the comma at the end there, so we continue on to the next line. And same thing down here, volume equals serial equals pub 001. Let's just look at the rest of this. Okay, so that's the end of the procedure. And then we call that procedure 6 times. You see passing in a different name here that is going to be substituted up in the procedure for the member name that we are going to restore. And then the member name is going to be part of the dataset name that we are unpacking to. So let's go ahead and run this. We'll submit that job. Number 28, look at our output queue. That ran pretty quickly. Let's look at the output. Okay, so this is exactly what the instructions said we should be looking for. Because we don't have an old version installed, the delete step is going to return 4, and then the receive step should return 0, because that's the step that we want to be successful. And if we scroll down here, we can see all those receive steps. Probably nothing too interesting to look at here, but we'll check it out just to make sure. These are all the allocations for each step. The actual output's down at the bottom. Yeah, here we go. So for each of those libraries we're loading, you can see that various members are being installed into those libraries. Okay. I'll purge that since everything worked. So the next step, I believe, was the install JCL. Let's go check the instructions. So install is going to copy the linklib and proclib members to our sys2 linklib and sys2 proclib libraries. It says that we won't be conflicting with any existing members. These are all named uniquely to BREXX 370. And it is telling us that we will need to log off and re-log into our TSO session before performing any testing. So we'll go ahead and run the install JCL, and then we'll log off and log back on. So let's look at the install JCL. We'll rename this MWilson I. We will change the message class to X. So it looks like we have an IEB copy step here, which is simply copying from dd_in, which is the BREXX linklib, to dd_out, which is our sys2.linklib. And then we will do the same thing, I'm guessing, for proclib. Yep, I'll scroll down. So we're doing the same thing, copying the members of proclib to sys2 proclib, and then remove BREXX CLIS members from sys2 command proclib. Okay, so I think if you had an old version of BREXX 370 installed, there's a last step here that will remove those. That shouldn't be applicable on our system, so I suspect these will just have no effect. It's also compressing our sys2 linklib and sys2 proclib libraries. I guess that's nice, right? Because if it deleted some existing members there, it's reclaiming that space. So that looks good. We'll go ahead and submit that. Check the output. Okay, we got the zeros for all of those steps. So, yep, so as expected, some members were not deleted because we didn't have an old version, so there's nothing to delete. Also looks like the compress command, that's not a built-in command. That may be a command proc that comes with the TK4 minus system. It looks like we don't have that on our system. Not a big deal. Nothing requires that those libraries are compressed to work. Just be aware that if we had deleted any members out of there, there could be some wasted space. So occasionally compressing those libraries is probably a good idea. But nothing to worry about there. It looks like that step worked for what we wanted it to do. And the instruction said to log off of our TSO session and log back on before we ran any testing. So let's do that. Okay. Back to the instructions. So step 5 is to submit the test Rx JCL. So there is a test procedure, and all steps should return a code of 0. So we're expecting all steps to succeed. Let's go into our BREXX install library and look at our install step. Let's edit that. Sorry, not install, test. Much better. Okay, so this will be MWilson T for test. That makes sense. We will make sure our output class is X. So this is going to set up a procedure here that will run through the tests. And then it looks like we'll just go ahead and execute that procedure for each of these test Rexx programs that comes with the distribution. So let's go ahead and submit that. Job 30 submitted. Start our output viewer again. And the test output. Okay, so this is what I was mentioning earlier on my system. We got this region unavailable message. That's an S822 append. And again, on my system, I am apparently not allowed to allocate a full 8 megabyte region for my jobs. So we'll turn that down a little bit. Let me just purge that output since we don't need it anymore. Switch back over. And for demonstration purposes, let's make it about 4 megs and submit this job again. Okay. Okay, so it's running now. We can see that it's on the primes step. I can just hit enter to refresh this page. And if we look at the output now, it looks like several of the tests worked, but then we got this OC6 system abend. Now, this abend code, I think, is a little misleading. If you look it up, it's something like trying to execute an instruction that doesn't exist, something like that. But I looked into this a little bit, and it turns out that the primes test script is in fact quite memory intensive. We're calculating primes up to 30,000, I believe. And for whatever reason, that's using quite a bit of memory. So reducing our region for this job to run from 8 megs to 4 megs isn't giving this program, this Rexx script, enough memory to successfully run to completion. So we'll go ahead and purge that output again. And there's a couple of things. If we want to get a clean run through of all of the tests, which I do want, we want to verify that this interpreter is actually running all those scripts correctly. There's a couple of things we can do. I can increase the region size so that it's big enough for the primes program. We can also look down here and see that the primes program is being called with a parameter of 30,000. So if we reduce the number of primes we're trying to find, that will cause this to run successfully. But I did some experimentation earlier and found that while I cannot give this 8 megs, I am able to give it 7.5 megs, so 7,680K. And that appears to be just enough to calculate the primes through 30,000. So let's submit this again and see if that works. Okay, so primes is running. It's been running about 15 seconds. It's working hard. We're up to 30 seconds of CPU time. Okay, so that job finished. Let's look at the output. And there we go. All of the tests ran successfully. So if you're installing this on a TK4- system, which does allow a region of 8 megs, I assume that test script should just work as is. But if for some reason, and again, I don't understand why on my system, I'm not sure what parameters in the system control how much memory is available for users to allocate to jobs. But if you need to go below 8 megs, just be aware that you'll either need to go just a little bit under 8 megs, 7.5 megs worked for me, or reduce the number of primes you're trying to compute. So let's scroll through this output. We can see, after all the allocations, okay, so here's the output from those various Rexx scripts. Looks like that's some kind of banner program doing some ASCII art. This looks like maybe just an output character test. Is this some kind of, is this a Fibonacci triangle, or is that Pascal's triangle? Something like that. Looks cool, whatever it is. This looks like it's making a kind of a 3D plot of something. Okay. I'm guessing this is probably testing some string manipulation. Here's all of those primes. So yeah, this looks like the output of primes up to 30,000. So there are 3,245 primes below the number 30,000. That's almost 5 to 8. Is that actually what time it is? Wow, yeah, it's actually 7:55. Okay, yeah, so it's 5 to 8. That's kind of cool, doing some time function testing. And it looks like it's probably trying to run the CLS command, which I have not installed on the system. So that makes sense that the CLS command is not found. And plotting a sine wave there. Okay. So the important thing, if we go back to the top, we did get a good 0 return code from each of those BREXX script executions. So it looks like our installation of BREXX works. Purge that output and back over to the instructions. So your tests. So at this point, I can write BREXX scripts and test them. I'm going to skip this step for the moment. And the last step here, well, maybe not the last step, I think there's a cleanup step, but step 8 is to add BREXX libraries into TSO Logon. So there is some recommended TSO commands, CList commands to add in the TSO Logon script that will allocate some libraries so that we can put Rexx scripts in various locations. And I believe if we scroll down here, yeah, so there's some documentation down here where when I run a Rexx script just by name with the RX command or the Rexx command, Rexx will search for a member with that name in these libraries in the following order. So if I make a library called mwilson, my user ID, mwilson.exec, I can drop Rexx scripts in there and the Rexx command will find them. It can search for a system-wide location and the sysproc location. So what we're doing, if I scroll back up, what we're doing by changing the TSO Logon script is allocating the libraries that we want the Rexx command to search for Rexx scripts in. So it will be able to find scripts in a system-wide library. So maybe as the system administrator, I want to make Rexx scripts available to all users. I might drop them in a library that I would create called sys2.exec. And users who you don't want littering the system-wide library with their own personal Rexx scripts can have a library called userid.exec, and then Rexx will run any scripts that it finds in there. And then it looks like the BREXX 370 distribution itself has some Rexx scripts that we can make available to all users if that library is present. So that all sounds good. What we need to do is include all of this in our existing TSO logon procedure. The documentation says that it's in sys1 command proc user logon. That is true on the TK4- system. On our system, I think it's called TSO logon, but we'll find it here. So let's go over to our mainframe again and just go back to our dataset browser, look in sys1 command proc, and we have our TSO logon script here. Let's edit that. Yeah, so this is our TSO logon script. This, by the way, is the one where when we log on to TSO, this will check if we have our own personal script called standard logon in our userid.clist library. If so, it will run that script. So that is how we're able to put commands in our personal standard logon script rather than using the system-wide standard logon script. But in all cases, this TSO logon script will run because it's the one making the determination of which scripts to run. And as long as we put commands before this %standard logon, those commands will run before we end up running either the user's script or our default system-wide script. So that's not information relevant to Rexx specifically, but that's just a little bit what's going on here with our TSO logon script. So what I want to do is above this standard logon line, I need to insert commands that look exactly like these. We'll use these as is. Everything's okay here. Now, copying and pasting from Firefox's PDF reader into my C3270 session through screen is just asking for disaster. So what I did earlier was I copied over that text from the manual into a member just in a library I have on my system here. So we can use the copy command in the review editor. And I can say I want to copy text above the standard logon line. So the copy command, and then I can say the line command A for above, or B for below. That will use A. So when I hit enter, review will prompt me for what is the sequential data set that I want to insert into this member I'm editing. And that's going to be where I created this little snippet earlier, which I think I put in my C list, and I called it, I think, Rexx init. Oh, you know what I did? Yep, I got it wrong. It's not A for above, it's A for after, and it's B for before. So let me, here, we'll do that over again so you can see that without. So I can cancel. Let me edit this again. I want to copy, and I want it, I guess, before the standard logon line. And that's the right file. Okay, that looks better. So let's go to the top of this. So we are doing that existing work. And then here are the new lines. And those all got inserted right before the % standard logon call. So that all looks right. We can verify in the instructions, you can see that that additional file I pulled in to this member is just the exact text that I had earlier copied and formatted nicely out of the manual here. So let's save this guy. So that's there now. The other thing I want to do, I'm going to go ahead and create my own BREXX library here. So if I look back at the instructions, you can see down here, I believe they tell you, yeah, so these Rexx libraries, they're recommending variable blocking with a logical record length of 255. So let's go back, and this is going to be called mwilson.exec. So I can go back here, and let's see, from the RFE menu here in utilities dataset, I can allocate a new dataset, mwilson.exec. I'm going to put that on my pub 000 volume. And that's going to be VB, record length 255. And what's a good multiple of 255 to use here? We can use 5100. I'm not sure what the ideal blocking is for this. We'll give ourselves, I don't know how much Rexx are we going to write. We'll give ourselves 10 tracks here, maybe 5 secondary space quantity and 15 directory blocks. So that'll create my mwilson exec library for Rexx scripts. Okay, up in the corner, you can see dataset was created. So let's exit, let's log off. Now let's log on, and this will run our updated TSO Logon procedure. So if I list allocations at this point, you'll see we now have that mwilson.exec data set is allocated. So we know that at least some of those changes we made to our logon CList worked. Let's go back into RFE. And now let's write a quick Rexx program. So in Wilson, we'll put it in this new exec library. And we'll call it, I'll call it hello MW for my initials. And we don't want numbering, so that's good. So we'll num off. We'll say caps off because we are able to use mixed case in Rexx. And we'll say my first Rexx program. And the only Rexx I really know is that you can do say. So I'll say, hello, Matthew, and Matthew's channel. Okay, so I think that's a valid Rexx program. Let's go to our TSO command prompt. So in RFE, we can use the shortcut to go to main menu option 6. And I should be able to say Rx hello MW. And it should find it in my mwilson.exec library because that's a data set that we allocated on login. And it worked. Hello, Matthew and Matthew's channel. So we have a working Rexx interpreter. We have it nicely integrated into our system so that we can just easily run Rx and then a member name that is a Rexx script in one of the data sets, one of the libraries that is on our, I guess, our search path or the Rexx interpreter search path. And I believe the last step in the instructions here was to remove old BREXX libraries. No, I think there's a... it looks like I skipped a step. I didn't run the cleanup JCL. So we can go ahead and run the cleanup JCL now. Let's go to our Rexx library again. Oops, not 3.8, 3.4. And the last JCL we had in here was the, I'm sorry, not JCL, but in the install library. Let's run the cleanup script. So we can call that mwilson C, change message class to X. And again, we'll need to change the region size here. This only needs, probably doesn't even need a meg. So this is just going to run TSO commands, delete BREXX v2r2 m0 linklib and delete BREXX v2r2 m0 proclib. So these are the two libraries where everything in them was copied to sys2.linklib and sys2.proclib. So we don't need to keep duplicate copies of that data around. So let's go ahead and submit that, and that should just run that cleanup quickly. Yep, no problems. If we look at the actual TSO output, you can see that it worked. They did indeed get deleted. So I think that's about it. Like I said, I don't really know Rexx, so there's not a lot that I can do with it yet before I learn a bit more. But I'd love to teach myself some Rexx and make some 3270 panels and maybe have some interactive user processing that we can do using this BREXX interpreter. Again, with the full screen support, with the VSAM support, we could make a little database and maybe have an entry panel and look up records in the database. So this should be a really neat tool and environment to have available on our MVS mainframe if we want to throw some programs together. So again, great work, Mike and Peter, who have, I'm sure, I can't imagine how much work had to go into porting a BREXX interpreter for, I think, Windows and DOS over to the S370 environment. And then integrating it so nicely into the environment so that we're able to use the capabilities of MVS like 3270 support and VSAM. You can do the address TSO so that you can run TSO commands from your BREXX scripts. So a neat system. I should also note that if you are wanting to install this on your TK4- system, again, the instruction manual that we were working through makes that assumption, so you should just be able to follow those steps. But Moshix also did a video on his channel, number M113, where he goes through the installation process on his TK4- system. So if anything I was doing here didn't quite make sense, or you just want to see another perspective on how to get this installed on that TK4- system, I'll link Moshix's video below as well, so you can check that out. But with that, thank you very much for watching. I hope you enjoyed the video. Feel free to give it a like and subscribe to the channel if you like to see this kind of mainframe content and want to see more. I really appreciate it. And until the next video, have fun.